I hope you all are good and doing well for the preparation of your A2 mathematics. Guys, the topic today we are going to discuss is about differentiation. And before we start the topic and its rules, we need to know a few things. The definition of this topic, definition of differentiation is it is a method used to compute or calculate the rate of change of a function with respect to its input x, because you know the function f of x, so it means x will be the input for the function, and this rate of change is known as the derivative of f with respect to x. Guys, generally we used to write d by d of x for the function f of x. This thing mean d by dx mean that we are going to differentiate what the function f of x with respect to x. So we need to write d by dx of f. If we will write like d by d of t f of x, it means we will say that now this time d by dt mean you are going to differentiate f of x with respect to the variable t, right? So d by d of u f of x, then this means you're going to differentiate f of x with respect to u. So these are the uh, things which you need to know if you are going to differentiate with respect to what variable. If it is x, so d by d of x; if t, d by dt; u, d by u, du, and so on. And before we start the detail of this, we need to know about the basic rules. As in AS we have done the basic rule of differentiations. So basic rules of differentiation. Although these rules will be assigned you in the formula sheet MF19 during the exam, right? But we need to know about few. In practice we will memorize this, and we need to know how these rules will be implemented for a certain question. The first one, the basic rule, that is if you have to differentiate the function f of x with power n, and you're going to differentiate it with respect to x, right? So we can say you need to write the power rule. So we need to write first power and write the function and make one less from the power of the function, times the third step is to differentiate with respect to x the function whose power you had, right? So we better can discuss this with the example that you have to differentiate x raised to power 5, say. Now function is x power 5, this one, and we have to differentiate it with respect to x. So as per rule number 1, you need to write the power or multiply the power in the coefficient. We get 5, make 1 less from the power, 5 minus 1 is 4, times differentiate the function whose power you had. This was x. So here you can see dx by dx cancelled, and we will write 5x raised to power 4. That is my final answer. Take another example of this. D by d of x, if you have 2x plus 1 power 5, then what to do? Now the function is 2x plus 1 power 5, and we have to differentiate it with respect to x. So as per definition, the rule 1, you need to multiply the power before the function, make 1 less from the power, times differentiated only the function. Here, let it be as it is, 2x plus 1 raised to power 4, and the differentiate of 2x plus 1 with respect to x is 2, as we already have discussed in our previous videos. So that comes to be final 10 times 2x plus 1 power 4 is my final answer, because 2 is going to multiply with 5. It can't be multiplied inside the function because that power is 4. I hope it is clear. Let's go to the next rule, number 2. Here this time, if you can suppose, let u and v be the functions of x. It means they are not constant with respect to x. We can differentiate them. This is function of x, like u is f of x and v is g of x, right? You can say u is what, f of x, that means, and v is another function, but both are a function of x. These are not constant. And if they are going to multiply, we call this rule a product rule. Product rule. And here we can call this power rule. Okay. Product rule says whenever two functions of x are going to multiply with each other, then what to do. And before we start, you need to know d by d of x of u, we can represent that v u prime. This means the result of its derivative, and result of the derivative of v with respect to x, we represent v prime, and result of d of x of f of x, we can say that is f prime of x. This symbol I will use frequently for the upcoming rules, so you need to know this one, right? Here, these are the symbols, you need to note it. Right, guys, so here come the product rule. You have to differentiate with respect to x the two functions u and v that are going to multiply. Then the rule says you need to write the first function like u as it is, times differentiate of the second function. I will write v prime, that's represent dv by dx. Okay, plus now write the second function as it is and differentiate the first one, that is u. So differentiate of u is here, we can say that is u prime. So this is the product rule number 2. After this, we have the quotient rule. We can say this quotient rule. Quotient rule means that here this time, instead of multiplying, the two functions are going to divide, like d by d of x of u over v, right? So here in product rule there was plus, so you can write in any order. Either you can first write differentiate u and then secondly differentiate v, it doesn't affect. But here you need to be very careful. The denominator function will first be written as it is, times differentiate of numerator function, that is u, minus, right, u times differentiate of denominator, and whole divided by the denominator function square, in square of the denominator function. This is the quotient rule, and after describing these rules we will solve few questions to practice over these. Okay, The next rule we can say is number 4, that is exponent rule, meaning for the exponential function rule. For exponential function, you can say this exponential function rule. Yeah, that is, we have two types of this, and we can say differentiate of e raised to power x. Instead of x, I will write e raised to power f of x. In the exponent, we have the function, and the base is e. If the variables come in the exponent function, exponential function, so the rule says you need to write the exponential function as it is, times you need to differentiate the function f prime of x, as we know this in note, that d by dx of f of x is f prime of x. It means differentiate of f of prime. And one more step is here. It was because the constant times natural log of what? The base in e. And you know, natural log of e is always 1 because its base is e, function is e, so it will be 1. So we can finalize this rule as e raised to power f of x times f prime of f of x. So this is the rule whenever you need to differentiate any exponential function, then you can use this rule. I'm going to highlight this. Yeah. Similarly, if I say this is what example, differentiate with respect to x2 raised to power x. Now you can see the function f of x is x and base is 2 instead of e. So as per rule, you need to write 2 raised to power x as it is, like function, times differentiate of the function f of x, that is x, times natural log of, here instead of e we have 2, so 2, and this cancelled, dx by dx cancelled. We will find d by d of x 2 raised to power x will be 2 raised to power x times natural log of 2. So this will be the answer of this question. Just applying this rule number 4 and you will get the results of exponential function. Right, similarly we have log function as well. Logarithmic function. So how to differentiate the logarithmic function? Right, here I'm going to write d by d of x of natural log of f of x. If you have natural log of f of x, you need to differentiate it with respect to x. So simple is this. You need to write 1 over function, whatever be along with x, along with log. We have log function f of x, so 1 over f of x times differentiate of f of x. This is the rule, and here is the rule. So take example of it. Say we have to differentiate with respect to x the natural log of 2x. For example, we have this one. So as per rule, we need to write 1 over 2x time differentiate, okay, 2x plus 1, we can write 2x plus 1, better, 2x plus 1 times differentiate what? 2x plus 1. What comes of it? We know that is 2. and 2x plus 1 is the final answer of this. I hope it is clear. Now few questions based on the trigonometric. Yeah, the proof of these the rules is not in your syllabus, but the application is truly over there. That's rule number 6 for trigonometry, and we have a 6 trigonometric function, so I will write d by d of x of 1 is sine of x. X is the angle, and we will write it laterally. Okay, 7 d by d of x. Let me write the functions, all 6. Cosine of x, 8 d by d of x of tangent of x, d by d of x of cotangent of x, cot abbreviated by cot, d by d of x of secant of x, and finally d by d of x of cosecant of x. Okay, so here the result I'm going to write. These are trigonometric, I can put the line here because these are trigonometric derivatives. Functions are all trigonometric. So here one thing important, those trigonometric functions which are going to start with c, their derivatives will turn up with a negative sign, like cos, cotangent and cosecant, right? And it is, you must know this, that starting with c must put a negative sign before you differentiate that. The rule says differentiate of sine theta is cosine theta, and times you need to differentiate this one with respect to theta. Theta is what, x here, so x will be here. That although goes, but you need to know this. I will do few example to make more understanding about it, why I wrote it. So cosine of x is minus sine of x times, again differentiate of the theta angle, tan is secant square of x, and differentiate of x. Because if I will not write this, a few common mistakes will be observed while solving the paper question. So we will do the example later on after explaining these rules. Cotangent is minus cosecant square of x, and differentiate of this angle x. Secant is differentiate of secant is secant x times tangent x, and differentiate of the angle once. And here cosecant minus cosecant of x into cotangent of x times differentiate of x, right? And these are the rules, and now I'm going to apply this on certain examples. We have y equal to, and you need to find dy by d of x. Y is given to be, say, sine of 2x. So as per rule, we have to differentiate with respect to x of both sides. I will write like this, and I'm going to differentiate now with respect to x on both sides. This side is dy by dx, what we are looking for, and right side will give us the answer. Look at now, this is sine and this is what, angle theta. Sine theta, as rule number 6 says, is differentiate will be cosine of theta times differentiate of theta, and here theta is not dx by dx, is 2x. So you know the differentiate of 2x will be 2. So our final answer is 2 cos of 2x. That is my final answer. So that's why this is the reason why I wrote this one. I'm going to highlight this. This is important. You must differentiate the angle in the last after applying the rules. Right? Now, are going to do some questions based on the multiple tasks of these all rules. Okay, here I can say find dy by d of x for the following. This is a general question. A part, let y is given to be e raised to power x times cos of 3x. Now here you can see we have two different functions. One is the exponential function and other is the trigonometric function that are going to multiply. So we will use the product rule with their individual functional derivatives. Let's see. We can suppose one is u, one is v. So product rule is very much clear here. I'm going to review. You can see the product rule says that here I'm going to number 2, and this was a quotient rule. So product rule accordingly, we will write dy by d of x to e power x times, we let u be and differentiate only v first, plus now write v as it is and differentiate the u, that is e power x. As we know, e power x will be as it is, differentiate of cos of 3x, cos c. So minus cos changes into sine of 3x. The rules already described in rule formula number 7. You can see the sheet here. I'm going to is 7 cos theta minus sine theta. Sine theta is 3x times the differentiate of what? Theta, that is 3x. Don't forget this second step along with it. Plus here cos of 3x times exponential function. We know e power x is what? E power x was like the same here, e power x times differential of power. Any function, we can say it will be e power x times differentiate of the power, and natural log of e 1, so no need to write it. So final answer is this will give us 3, right? So I will write minus 3 e power x sine of 3x plus e power x cosine of 3x is fine. Or if you want to simplify, you can just take the e power x common. You have minus 3 sine of 3x plus cosine of 3x. That should be the better answer for this question. I hope it is clear. Let's do another example. We have to find dy by dx for y equal to, say we have natural log of 3x plus 5 divided by x square. So what to do? Here you can see we have two functions. One is log function, one is a quadratic function that are going to divide. So we will use quotient rule and this was in formula number 3. We will apply it directly here, and you need to keep that. The formula sheet will be assigned with you during the exam. So first write v as it is times, we need to differentiate with respect to x what? Log function plus and minus, the question mean minus here, natural log of 3x plus 5 numerator times differentiate only denominator and whole divided by denominator square. So we will get x square, and you know differential log function is 1 over function times differentiate of function. Once guys you will get command on these working, you can do it directly. Instead of writing this, you can write directly here 3. That is acceptable, right? If you write directly 3 here, it's fine. But first get grip on the concept instead of doing wrong in the exam. So x square derivative, you know that will be 2x over x square means x4. So I can write x square over 3x plus 5, and this derivative is 3, so 3x square minus 2x natural log of 3x plus 5, and this whole is going to divide with x4, so I can write 1 over x4 here. That is my final answer about this question. I hope it is clear. Take more questions. Say y equal to cos cube of x. Yeah, this time we have the trigonometric function with the power rule. First we will apply power rule, then go with the trigonometric function. Let's see how. It's dy by d of x equal to d by d of x. First I'm going to write the steps, then I'm going to differentiate with respect to x. Keep one thing clear guys, here I'm going to write in note. Might be in few students mind this thing comes, cos 3x is not equal to cos of 3x, because this is the power and this is the angle. So you can't take anything from the angle outside or from outside to inside with the angle and power can be written like this, right? So here we will apply the power rule. We will write power, we will make 1 less from the power and times differentiate the function whose power we have, that is f cos of x. So I can write 3 cos square of x, not cos x square, because one more thing you need to write, cos square x is not equal to cos of x square, right? This thing you need to keep in mind, because this is with angle square, this is function square, so don't confuse this thing. Times here differentiate of cos theta is, we know that, minus sine theta, times differentiate out the theta is what, x. So must I suggest to keep carrying this step. It will be minus 3 cos square of x times sine of x. This will be the answer. I hope it is clear. Let's proceed to another questions to end this concept. Almost everything done. In D part we have y equal to, say we have cos 2x times, let's say, sine square x. What to do now? Here we have cos of theta. I can write this as cos of 2x. I told you I can't take this 2 out from it. So two trigonometric functions are going to multiply. Let's suppose one is u and one is v. So we apply the product rule because they are going to multiply. Here product rule. So that will define dy by d of x as, first we will write first u times differentiate what, sine square of x, any sine x whole square, plus sine square of x as it is, and we will differentiate cos of 2x, right? So cos of 2x here as it is a power rule we applied here. We write power, make 1 less from the power, times differentiate the function whose power we have, plus here the sine square of x and cos of theta will be minus sine of theta times differentiate of theta. Don't forget the rules, the basic concepts. So we have here 2 cos of 2x times sine of x times. So differentiate of this will be sine theta is cosine of theta and differentiate of theta dx by df here cancelled, plus okay, plus minus is minus sine, here this comes give me 2, so 2 sine square of x times sine of 2x. I can't take this together because it's double angle is single angle, so keep this in your mind. Maximum I can take few things common, or I can write 2 cos of 2x into sine of x into cos of x minus 2 sine square of x into sine of 2x, right? No need to further simplify until it's demand in the question. So you have differentiated, that's your answer. I hope it is clear. So rest of the few more things which we need to discuss in differentiation we will discuss in the next video. See you guys, good luck.